to use the restroom, use the restroom. You know how to be appropriate. Okay, so we are live after school with the Thursday group. Everybody say hi. All right, we're going to start off going over the first paper. You should see somewhere that it says, not Cavalari's principle, my fault. We're going to go to circle properties first, but let's look at these two volume and density things before we do that. According to the blueprint, you're going to have at least, you don't have this paper, so for the next 5 slides, you don't have that. According to the blueprint, there's going to be at least 1, if not 2 questions on this idea of Cavalier's principle. And if you came to my EOC review, I had a picture of me standing next to a picture of Zoe Saldana, who played Gamora in Infinity Wars and Avengers, because she and I are the same height. But we can tell I'm going to take up more volume than she does. So the 3 main things that you need to know, and you can write this on your paper, is if you see something that says parallel planes, cross-section equal area, then you can know that, gosh darn it, it's going to be something with the volumes being equal. So you might see a question where you have like a stack of quarters, and the quarters are tilted one way or the other, and they want you to come up with a volume. That's an example of a review problem that you saw. So the main concept is, as long as the height is the same, and when you cut it going across, as long as each of these areas are the same, you know the volumes are the same. Next, you're going to have at least 1, if not 2 questions on cross-section. So this is just to remind you. For a cylinder, if you cut a cylinder parallel means across, perpendicular means up and down. And I think of it like the letter D kind of almost forms a right angle. So that's how you know perpendicular right angle. So going across, you can get a circle. If you cut a cylinder on the diagonal, you could get an oval. And if you cut it on the perpendicular, wrong pen. If you cut it on the perpendicular, then you're going to be able to get a rectangle. So one of the review packets, don't pay attention to my blue rectangle. One of the questions in the review packet, it mentioned something along the lines of like, which one of these cannot be found in a cylinder? Then you would say, well, whatever shape, maybe a triangle or something like that. For a cone, the shapes that can go in a cone is a parabola, which I highly doubt you're going to get asked. A circle if you go straight across. An ellipse, which is just a fancy name for an oval. Or if you do the perpendicular in a cone, you're going to get a triangle. For a pyramid, again on the perpendicular, we're going to get a triangle. Pay attention to what kind of base they tell you. If they tell you that the pyramid has a square base, then when you cut the parallel, sugar shoots, when you cut the parallel, you're going to get a square. But if it tells you it has a rectangular base, when you cut that parallel, you're going to get a rectangle. So pay attention to what type of shape pyramid they mention it. You can also get a trapezoid if you cut on the diagonal, and then this is only a square because this base is a square. For a sphere, you pretty much get a circle. This is stuff I didn't know. Here's some things I learned about the cube when I was looking at cross sections. So I did know if you cut a cube on the diagonal, you can get a rectangle, because we know a cube, all the sides are the same. So if you think of like Pythagorean theorem to get you that angle, if you cut the corner off of a cube, you could get a triangle. If you cut it from the top to the bottom, you can get a trapezoid. This one I had no idea. This is actually a pentagon because there's 5 sides. It's just not what's called a regular pentagon because all the sides aren't the same. But you can get a pentagon out of a cube. I looked that up this month. And then also you can get a hexagon. So pretty much think of it that because a cube has 6 sides, the biggest shape that you could get has to also have 6 sides. So you couldn't get like an octagon or a 10-sided figure. The biggest figure that you can get in a cube is a hexagon because a cube has 6 sides. Now we're on the papers you have in front of you. Please find the paper that says circle properties. These are just some things to refresh your memory. For circle properties, we talk about having a central angle, and we talk about circle properties that the central angle is the center. You might have seen my Snapchat video that's on the YouTube channel where it's like a central angle wants they want all the attention. So whatever this angle measure is, if this is 40 degrees, that means that this central angle is 40 degrees. The central angle is the specialist angle, which specialist isn't a word, because it's the only one that you never have to divide by 2. For the inscribed angles, you do have to divide by 2. We did something in my class where we did arc to angle divide by 2, angle to arc you multiply by 2. That deals with inscribed angles. So if this measure is 80, 80 divided by 2 gives you 40 for this piece. Interior angles, interior angles form an X, and the way that we do it is we have to add the 2 intersecting arcs. So we would add this arc plus this arc, and then of course divide it by 2. Exterior angles, if you have Emmons, I think she told you like big arc minus baby arc divided by 2. I said big arc minus small arc divided by 2, anything like that. Now, your test is made of 26 questions. 24 of them are DOK2s, which means it's not going to be like a simple answer to this question. You're going to have to think. So they might give you, like if in this question, they might tell you that this is 25 degrees and this is 10 degrees. How much is this one? So you'd have to work backwards. You'd have to be like, well, I know I have to subtract big minus small divided by 2 is going to give me that 25. And then you'd have to solve it. Who's got how I'm going to solve it? What do I do to get rid of that 2? Yeah, that's right. We multiply by 2. These would cancel. So I'm left with x minus 10 equals 50. Add the 10 to both sides, and that's how I get my x equals 60. So you will get, I think it said on the blueprint that there's 1 or 2 questions dealing with angles. So you just have to remember that just take your time. You're going to have 90 minutes to do 26 questions, which means each question you can invest 3 minutes in. Some questions will take you less, some will take you more, but use the time. Don't feel like you have to rush through it. I am going to continue going, even if you don't have it written, because it is on, you'll see it on YouTube. There's 4 special cases that deal with angles and circles. Here's one special case. Because we talked about an inscribed angle has these points on the circle. So we know a diameter of a circle is 180 degrees. So because of that, if you have an inscribed angle that has its endpoints on the diameter, it actually forms a 90-degree angle. And so you might have the question where you need to know that information, and then they expect you to do something like the Pythagorean theorem, something like that. Over here, you will probably have a question that deals with this concept. Unlike a parallelogram where the opposite sides are congruent, when you have a shape that's inside of a circle, the opposite angles are supplementary, meaning that they add up to 180 degrees, and we'll look at an example of that. Another thing to remember is when you have tangents. There's 2 things to remember with tangents. One, if you have 2 tangents coming from an exterior point, each of these measures are the same. So if this is 10, you know this is 10. Here, if you have a radius and a tangent, the radius and the tangent always forms a right angle. So in that case, if they give you, let's say this angle measure right here is 30, well, we know because this is a central angle, we can go central, same, 30, 30, and then we'll be able to get our last piece right here. In which case, 90 plus 30 is 120. When we subtract, we can discover that that's 60 degrees. So those are the main special things that you have to remember. Let's talk about a couple things dealing with segments. Segments are kind of funkity-dunkity. Here, we did something, it looks like exterior angles, but because it mentions segment measures, you have to remember the formula that's part times part. So like if this says 7, and this says 8, and this says 4, and we need this piece, we would do it 7 times 8 equals 4 times x, and then we just continue doing the math problem like we did back in algebra. So we know x has to be 14. So doing those types of things. Other things to notice. If they mention the word parallel, that means that this little piece and this little piece have to be the same. Down here, if they tell you that these pieces are the same, then you know that they're also the same length. So just kind of pay attention here to the pieces. I'm saying pieces a whole lot. This is something I want you to think about. This is my Sleeping Beauty problem where I call it OW, which is the outside times the whole equals the outside times the whole. You might have seen the formula look like this. A plus sugar shoots. It doesn't say that. A times A plus B equals C times C plus D. So if your teacher had you do delta math, that's the formula that delta math taught you. I taught my students OW, which is outside times whole equals outside times whole. Another thing to remember, this is another one of the special cases. If you have a chord that forms a perpendicular angle, it's actually a hidden perpendicular bisector. And so because these two pieces here are radii and are the same measure, you can prove because of hypotenuse leg that the triangles are congruent. Let's do some, sugar shoots, we're almost there. Okay, other things to remember with circles. Remember that a diameter cuts a circle in half. The diameter always has to go through the center of the circle. So if they give you the diameter and they tell you the whole diameter equals 10, you have to know the radius is 5. You're gonna see that come up when you do equation of a circle. Also, you might have to add or subtract to figure out what the missing angles are. So that's another piece that you need to know. Also, there is definitely going to be at least one question on area of a sector or arc length. Please use the correct formula. Today, one of my students got a question wrong on her strategies geometry final because the question asked her to find one of the two things and she found the other one. So read it. If it says what's the arc length is like the crust of the pizza. If it says the area of a sector is like the actual pizza that you're going to eat with the pepperoni. Next, all circles are similar. You are going to have at least one, if not two questions on this because that's what it says on the blueprint. So what that means is, and we're going to do a problem next, it's on the bottom of your paper. This picture you don't have. You're going to have to look for two things. You're going to have to look for a translation and you're going to have to look for a dilation. And we're going to do that right now. The reason why all circles are similar is pretty much because of the circumference formula. The circumference formula says the circumference equals pi times the diameter. So basically, it's because of the ratio in the diameter. Everyone, let's say that 3 times. All circles are similar, ratio to diameter. Ready? All circles are similar, ratio to diameter. All circles are similar, ratio to diameter. All circles are similar, ratio to diameter. Okay, so let's look at some problems finally. Yay, we could use our brains. So it says, describe the transformation that happened. You can go right this way, you don't have to be fancy. So we have circle A to circle B. Pay attention to how it moves, okay? So basically, one of the review sheet questions, it gave you 3 circles and it only talked about 2 of them. So pay attention to which one they're doing. Also, when you do something with scale factor, which is what we're going to do for dilations, you have to remember that it's the new over the old. So I say, oh no, new over old. So here, first of all, remember, we will always have a translation. We will always have a dilation. Those are the 2 things that you'll always have. So for the translation, how did I go, if we say A to B, how did I go from +2 to +1? What happened? Down 1, okay? It might say left 1, okay, but we went down 1, because basically, it's not saying down, but she's thinking backwards 1. Because here's where +2, 7 is up here. 1, -4 is down here. So we had to go 1 space to the left. That's why it's negative. How did we go from +7 to -4? What did we have to do? Yep, we had to subtract 11. So that's our translation. Now we have to discover what is the ratio. The ratio is always what over what? New over old. So what is our new radius? What's our radius for circle B? 3. What's our radius for circle A? Done. Problem's done. So you're always looking for 2 things. It's not asking you to solve anything. It's asking, how did the circles move? First, we subtract or add to figure out its translation. Then we do division to find the scale factor. So let's look at the next one. It says A to B. We start at +8 for the x, and then we go to 6. So how did we get from 8 to 6? What happened? We start at 8 and we go to 6. Subtracted how many? 2. How did we go from 1 to -4? Subtracted how many? 5. So we know that we did x minus 2, y minus 5. Then we have to come up with the scale factor again. What's my scale factor? Who's got it? 8 over 6. Now they probably won't tell you 8 over 6 on your test. They'll probably have the fraction reduced, which would be 4 over 3. Let's look at the next one. This one's trickier. First, what's the center for circle A? Who can tell the center in circle A? Why is it 2, -6? You're correct. Yeah, you have to switch the signs. The circle formula is on your formula sheet. We have to switch the signs. What's the radius for circle A? 4. Why is it 4? Yep, 4 squared. The formula will tell you r squared equals 16. So we have to take the square root. That's why we're reviewing. It's okay to make mistakes right now. Totally okay. That's why we're reviewing. Who's got B? What's the center for B? -4. What am I going to write down for the y? 0. Why am I writing down 0? There's nothing there. What's my radius for circle B? Why is it 5? Woo! All right, so now what am I going to do? Who's got the translation? How did I go? If I was at +2, how did I get to -4? I subtracted how much? If I subtracted 2, that would put me at 0. So I was at +2 to -4. 6. I subtracted 6. Then it was at -6, and I landed at 0. What did I do to get from -6 to 0? I added how much? I added 6. So I'm going to have x minus 6, y plus 6. And again, they might say something like it moved left 6, up or down 6. It might say that. What's my scale factor going to be? 5 over, why is it 5 over 4? New over old. We good? You're going to see at least one question like this. I'm going to go on. Okay, here we go. A circle is drawn to represent a pizza with a 12-inch diameter. Look at it, tells us my diameter. What am I going to have to figure out right away? The radius. What's my radius? Okay, it tells me the pizza was cut into 8 slices. Why is that piece of information important? Theta. How do I find my theta? How many degrees are in a circle? 360. I'm going to divide that by 8 because there's 8 equal pieces of pizza. So I'm left with 45 degrees. Now it says, what is the length of the outer crust? Am I going to use area of a sector or am I going to use arc length? And the question is, what is the length of the outer edge? So am I going to use, I'm going to use arc length. And it literally says, what is the length? So I'm going to use arc length. So the arc length formula will be on the formula sheet. I know you don't have it in front of you. That's pi times, 2 pi r theta divided by 360. So then we're just going to put it in. We're going to put in 2 times pi. Our radius was 6. Our theta was 45. And all of that is divided by 360. All of these answers have pi. Why is that important that all of these answers have pi? Don't include it in the formula. 2 times 6 times 45, that's going to give me 540. Then I've got pi divided by 360. Let's say you stink-a-doodle-doo when it comes to reducing fractions. So what you can do is ignore the pi and get the decimal. So if I type in 540 divided by 360, that gives me 1.5. And then pi. So now I'm just going to do each of these fractions. Well, 3 divided by 4, that's going to give me 0.75, so I know it's not going to be 1. Here, there's no number, so that's just plain 1, so I know it's not going to be 2. 3 divided by 2 on the calculator gives me 1.5. That's what I'm looking for, so I know my answer is choice 3. So if you stink at reducing fractions, that's something else that you could do instead. Here's an example of the inscribed. Tell me about the opposite angles in an inscribed quadrilateral that equal what? Each other or 180? 180. So PQRS is an inscribed quadrilateral and the side PS is extended. If angle PQR is 80, what is ASR? Let me think for a second. So here's PQR. So that's 80. So this whole thing here has to be how many degrees? What type of angle is that? Inscribed. How do we go from angle to arc for inscribed angles? Arc to angle we divide by 2. Angle to arc we do what? Multiply by 2. So what's 80 times 2? 160. So we know this whole arc is 160. We have to figure out, though, how many degrees is this? How do we know how many degrees that is? Yeah, 180 minus 80. So we know this is 100 degrees. And actually, I gave you way more work than you needed to. So now how many degrees is left for this piece? 80. You didn't even have to do the whole angle to arc thing now that I think about it. It was just a simple linear thing. Opposite angles are equal to 180. A straight line is 180. So I did make you do extra on that one. In the accompanying diagram, O, chords AB and CF intersect. It tells you EB is 16, AE is 5, CE is 10, and it wants to know this piece. This is a classic part times part equals part times part. So what the part is this little intersection. So we're going to do 5 times 16 equals 10 times x. 5 times 16 is 80. What do I do now? Yep, so what's my answer going to be? Beautiful. Part times part, that's all this is, part times part. CP7, we have in the company diagram, we have arc AB is 132, arc AD, or no, BC is 82, find ADC. This is just a simple ice cream cone inscribed angle. Here's my arc. I have to just add up these pieces, that's it. 132 plus 82. So now I know this entire arc is 214. How many degrees does angle ADC have to be then? No. How do we go arc to angle? Divide by 2. So you get 107 degrees. So don't forget, you might have to add arcs together, subtract pieces out. If it has a diameter, it's 180 degrees. And then you might have to do something else. Oftentimes, the something else will have you do something from angle to arc or arc to angle. That's usually what's going to end up happening. We go on? Because the whole arc, this major arc right here, that went from, why are you not moving? That went from here to here, this was 214. And we do arc to angle. So 214 divided by 2 gives you the angle. That's how we divide it by 2. Next, you'll probably see something like this. This deals with the tangents, the whole idea of tangents. So basically, let's fill this in and then we'll deal with what the question's asking. This is 24. Because it tells us all these are tangents, that means this is also 24. Because this section right here is 20, that means this section is 20. Because this whole side is 32, how much is left for BF? 12. And because BF is 12, BG has to be 12. So now we can figure out what it asks us for. It asks us to find BC. So how are we going to find this thing? What do we do with those two numbers? Add them up. BC is going to equal 12 plus 24. That's it. Sure, because this whole side said 32. So because I knew this piece was 20, because this piece was 20, 32 minus 20 left me with 12. So you just kind of have to work around in the circle. Here it tells us that this entire arc around this way is 268. It wants to know this little teeny weeny angle here. Who's got an idea? Excellent. Subtract from 360. We know an entire circle has got 360 degrees. When we subtract, we get this is 92. Is that our answer? It gave us the major arc, so we had to subtract to get the minor arc. So yes. Now we have to divide by 2. Why are we dividing by 2? We're dividing by 2 because we need this little angle. If it was a central angle, then we wouldn't need to divide. But because it's an inscribed angle, we have to divide. Okay, 2 more things I want you to see. Find a space to draw this picture. There should be like a blank space on the note side. If you have a circle and you have an inscribed angle and you have a central angle that touches the same arc, what that means is if this is 30, this has to be 60. Because what happens is we do 30 times 2 to give us the 60, and then because these are central angles, they're the same. So I just want to make sure you have that picture drawn. Here's one more picture to draw. If you have a circle and you have 2 inscribed angles touching the same arc, pretend they're touching the same arc. Those 2 angles are both going to be the same. And they're going to be the same because this is 40, arc to angle multiplied by 2. This is 80, or divide by 2, angle, arc to angle. Yeah, you know what I mean. Angle to arc multiplied by 2, arc to angle divide by 2. So if you see the overlap, that's what that is. We good? Equation of a circle. Equation of a circle is on the formula sheet. That's the next paper we're going to talk about. Remember, for equation of a circle, here are some things to know. This is what's on the formula sheet. We're subtracting because we're always trying to go home. So whatever the center value is, you're going to end up switching the signs. So and then you also will need to know this process. So for example, here, if I have x plus 4 squared plus y minus 7 squared equals 100, I'm going to switch the signs for the center, and then I'm going to take the square root of 100 to get the radius. Okay? All right, let's look at this one. Here, you are probably going to have a question that deals with this because it's a DOK 2 level question. So you have to remember how to complete the square 2 times. So it's written down for you so you can follow along, but I want to demonstrate it. It tells us x squared plus y squared minus 2x plus 4y plus 1 equals 0. So my process is I tell my students to group the x, leave a space, group the y, leave a space. So I'm going to do x squared minus 2x. This should be on the front of your paper. Leave a space. Then I'm going to group my y's, leave a space, and then this has to go to the other side. So because this says plus 1, the inverse operation of adding 1 is subtracting 1. So this is actually going to equal -1. So now I have to just write the formula that I get right from the formula sheet. I know I'm going to do x something squared, y something squared equals, and we don't know. So the way that you complete the square is we divide by 2 going down, and then we square going back up. So for example, for me to get from -2 to this space, I have to divide -2 by +2 because I need half of it. And there's other videos I've done that tell you why it works. Last year in algebra, you might have done something with the algebra tiles and the blocks and you had to fix the mixing thing. That's the concept. Once I do that, I have to square this going up. This is where you're going to get it wrong. Some kids see this -1 and they think -1 times -1 is -1 still. You have to remember that anytime you square a negative, it will always become positive because a negative times a negative is positive. So how here, when I square this going up, don't just put -1 in the calculator without putting it in parentheses because your calculator will give you the wrong answer. So there's a +1 here, and whatever you do to one side of the equation, you have to make sure that you do to the other. Now going back, here, going down, I'm going to divide by 2. 4 divided by 2 is +2. +2 times +2 is +4. And then I add this 4 here. So now I just combine this. -1 plus 1 is 0. 0 plus 4 is 4. So that's how I got the equation. Can I have one of my students go to my room for me for a second? Jasmine, her hand was fastest, that's why. You know where you go, right? At the very bottom. Yeah. Okay, let's look at some questions, or let's look at some more things. Other things you need to know, and I would just, if I could have one prayer, I got a lot of prayer for you. But please remember these things, okay? The center of the circle always will have opposite signs like we just did. So you're going to have to switch the signs if you go from the formula to the center or the center to the formula. Next, the radius of the circle is squared. So you're going to have to take the square root, just like we just did. If you're given the center of a circle and a point, you need to use the distance formula. And I'm going to show you that in a second. If you are given the diameter, you might need to use the midpoint formula. That midpoint formula is going to tell you where the center is. And then from there, you can use the distance to find the length. Also, don't forget things about in, on, and outside. I'm going to give you an example about that, but we're basically comparing the radii. And then this one, let's talk about this real quick. You probably saw it on the performance final. If it asks for the equation of a tangent, all that wants you to do is find the perpendicular slope. So if here's my circle, and it says, what's the equation of this tangent line? What you're going to do is find the slope of this line. Let's say it's 2. Then you're going to find the opposite reciprocal of this line. So it'd be like -1/2. So for the tangent, you find the slope of the radius, and then you do the opposite reciprocal to get the slope of the tangent. And then from there, you can plug it in to do parallel perpendicular. All right, let's do questions. Okay, looking at circle A. Circle A is this big, huge circle. What's the center of this big, huge circle? Who's got the center of the big, huge circle? You locked up too? Thank you. Who's got the center of circle A? 0. Yep. So technically speaking, we could put +0, +0, but that's not good math. We'll just leave it blank. What's the radius of circle A? So what am I going to put right here? 16. Circle B is this little teeny weeny circle over here. What's the center of circle B? +2, 0, because we always do x first. So that means here I'm going to put the opposite. So this is going to be -2. And then my radii, it's hard to tell, it's actually 0.5. So this is going to be 0.25. Okay, what is circle C? Is this little baby here? Who's got my center for this one? for C? -2, 0. So what am I going to write in here? +2. And then again, the radii are the same. 0.5 squared will give you 0.25. Let's look at circle D. Circle D is a semicircle, so we're not going to even bother with it. Let's move on for time. Okay, EQ2. Do anyone else need to get this? We're good? We're not going to do D and E because they're semicircles, and I don't think you'll see it tomorrow or this week. Okay, E2, again, I'm going to do this one a little bit quicker because I want to get through this, and I already did it one time slow. So we're going to group the X's, which they already did for you. Then we have to leave a space. Then we're going to group the Y's. Then we have to leave a space. And they already moved the 23 to the other side. So you got a head start. Now we're going to do it here. Here we've got our X. Here we have our Y. How do I go down again? What do I need to do? How do I get that number? Divide by 2. How do I get this number? Square it. Okay, what's this number going to be? Excellent. What's this number going to be? There you go. I like it when you pay attention, man. Add them all up. This becomes 36. So what's the center of my circle going to be? -3, +2, and what's my radius going to be? Now, let me show you how they could try to trick you. Let's say that number instead equaled 17. So that means that your radius is going to be the square root of 17. Let's say they tell you that your radius is the square root of 23. That means that you would have it equal just plain 23. So that was one of the things on the interim, because remember we got to look at your interim questions. That was one of the things you guys missed the most, is that if they gave you something that wasn't pretty, did you remember to square it and take the square root sign on and off? This one, I'm going to just tell you, I'm going to do this one even faster. This is going to be so much for faster. The answer to this is going to be x minus 1 squared plus y plus 3 squared. And then -3, 1 squared plus 1, 3 squared plus 9, 10, 7. So then your answer is going to be choice 2. So you can do that more slowly later. I just don't want to take time showing you how to do it because we've done it 2 other times. Okay. Next, which point is on the circle? Here's the easiest way to do this problem. Because they give you an equation, dude, just substitute. That's all you got to do. So what you're going to do is say, okay, well, is -12 squared plus 12 squared, what does that equal? Well, that's 144 plus 144, which is 288. Does 288 equal 289? No, so it's not choice 1. Here I've got 7 squared plus -10 squared. 7 squared is 49. 49 plus 100 is 149. Does 149 equal 289? No, so it's not choice 2. Then I'm going to put -1 in. -1 squared, 16 squared, -16 squared, 256. Does 257 equal 289? No. So it's got to be choice 4. That's going to give you 8 squared, which is 64, plus 15 squared, which is 225. So they equal. So it's choice 4. Coincidentally, because this one is smaller, this one would be inside, this one would be inside, and this one would be inside. If that number was larger, like 300, then it would be considered outside the circle. Which equation represents the circle whose center is here and passes through this point? This is when we're going to have to do the distance formula to find the radius. I'm going to give you the distance. You know what? I'll do it the right way so people don't get confused. So the distance formula says subtract the x's, square it. subtract the y's, square it. So this becomes addition. So I'm left with 4 squared plus 0, which gives me 16 plus 0, which gives me a radius of 4. So the distance formula is on the formula sheet. Your main thing that you need to do is pay attention to what these are. This would be x1, y1, x2, y2. So now I just solve the problem, or I just plug everything in. I change the signs going into the equation, and I square the radius. We good so far? Coordinates of the endpoints of the oh. Guys, I know you signed in her sheet. I also need this sheet. So can you please sign in on this sheet too, coming around? Alphabetical by first name. Everybody. Yeah. So I'm tracking who attends, so that's why I want it passed. Your teacher may or may not see it, but I've been going through the EOC to see how many kids who come to my review did well in the EOC. That's it. So I want to see, that's why I'm tracking it. Okay, next. Coordinates of the endpoints of the diameter of a circle. Because it gives us the diameter, we need to get the center. What formula do you have to know to get the center? If your name's not on it, put it on the back, or you'll see empty spaces. Okay, midpoint. For midpoint formula, we add the x. 2 plus 2 divided by 2, 4 divided by 2. So our x equals 2. Then we add the y's, divide by 2. So what's my midpoint? 2, negative 4. So how am I going to get the equation in here? What am I going to get? Actually, we don't even need it. It just wants the coordinates. Oh, no, it does want the equation of a circle. So what am I going to do? Yep. How do I find the radius? No. How do I get the radius of a circle? Divide the diameter by 2. How do I find the length of the diameter? Distance formula. Yep, you were on it. You were on it. I'm not going to do the distance formula, but that's what you would do. You would do the distance formula, get the diameter, and then divide it by 2 to get the radius. Okay, I'm not going to show you how to do it. I have a video that goes through this too, but that's how you do that piece. Need a second? Okay, so next, yes? Okay, so here we're just plugging it in. We've already done it, but I do want to do this for you so you can see how to check your answers. Because it says, is it on, in, or outside, all you do again is plug in the points. So I've got here, this is my x, this is my y. So I'm just going to plug it in. Negative 4 plus 2 squared, plug in my y. Negative 1 plus 5 squared. And I want to know, what is its relationship to 25? So then I've got this, I simplify it. This gives me 2 squared. This gives me 4 squared. 2 squared is 4. 4 squared is 16. So 20 and 25. Is 20 smaller, equal, or bigger? It's smaller, so it's inside. So I'm not going to do that for every single problem, but that's the process. You either find the equation of a circle if you need to, then you're going to plug in the points, solve it, and if it's the same value, then what you're going to do is it's going to be on. If it's bigger, it's going to be outside. If it's smaller, then it's going to be inside. Ma'am.
If it's will it ever be like the plugging for X or Y?
Yep, it'll say. Yeah, it might give you the center. So that's actually where this came from, is they gave us the center here. So first we got the formula, then we plug this stuff in. Yep. Let's look at this one. Here it says, write the equation of a line that is tangent to the circle at this point. So remember that what we need to do is first we need to find the slope. So you're going to take the center of the circle. So my center that they gave us was at -2, -5. Then you take the point that they gave you. This part is one thing I really wish you could remember. -6, -2. So what we have to do is first we have to find the slope of that line. How do you find slope? This is from 7th grade. No. There we go. Y2, pardon me, minus Y1, X2 minus X1. That's how we find our slope. So we're going to do -5 minus -2, -6 minus -2. These become addition. So we're left with -3 over -4, which gives us +3/4. Now it gets harder. Now we have to find the perpendicular because tangent lines are perpendicular. So what's my perpendicular slope? Excellent, which is going to be what? -4/3. Now we have to find the B term. Who remembers how to do the B term? Y equals mx plus b. So now we're going to plug, I'm going to go up here. Now we're going to plug all that stuff in. So what we're going to do is, it's fine that I erased too much. Pen, pen, pen. So I'm going to plug in, they give us 6, -2, -6, -2. So I'm going to plug in -2 for y. I'm going to plug in my slope. I'm going to plug in my x, and I'm solving for b. We're still not there yet. We're just solving for b. So now we have, this becomes +8 when you do it on a calculator. Trust me, I've done it so many times. Now we have -10. So what's my final equation after all of this ridiculously hard work? Y equals my new slope, my new b. It's long. I would rewatch this video like 3 times on that part. So first we had to find the slope based on the center and a point. Then we had to find the perpendicular slope. Then we had to find the b value. And then we had to plug it in. I know, that's a beast. We good to go on? Okay, geometric modeling, we can do it in 12 minutes. All I'm going to say is you got to know all of this. The only thing I need you to write down is I forgot underneath proving a rectangle. Notice underneath proving a rectangle, I added the words, the diagonals are congruent. So please find that, and underneath the rectangle, please write down diagonals congruent. I completely forgot to mention that. Underneath the prove a rectangle, see it right here in red? I'd like you to write diagonals congruent, because that was one thing I forgot. Okay. Yep. So if they give you like, what quadrilateral has diagonals congruent? You're going to be like, rectangle or square, because a square is a rectangle. Okay, we are almost done. You're doing fantastic. Please be patient. Slope formula, we just went over, subtract the y's, subtract the x's. Midpoint formula we talked about already, add the x's, divide by 2, add the y's, divide by 2. Distance formula I already showed you too, so that shouldn't be new. Here's something that you need to see. I didn't get to see the pretest, but I had a number of my students say, Dr. Eric, how come I saw trig on the pretest? So because usually the pretest is the same as the post-test, you might see trig. So let's remember trig real quick. For this, you're going to have a squared plus b squared is c squared. That's on the formula sheet. That's the Pythagorean theorem. You get that when you see the missing side. Then you might also need SOHCAHTOA. SOHCAHTOA is also on the formula sheet. Bye guys, thank you so much. Clean up your stuff, I love it. Good luck, good luck. So they might give you 1 or 2 sides and then you're gonna have to do SOHCAHTOA. Remember, everything is based on wherever the theta is. That's the most important. Where is theta? Directed line segment, if you see the word partitions, it's gonna be coming right from the formula sheet. So you're gonna plug things in. Here is where they might try to trick you. Here, it tells you it does it in the ratio of 2 to 3. This one says 3/5 of the distance. So you have to think, well, if it's 3/5 of the distance, that means my total distance is 5 spaces long, and I need to make my mark 3 spaces down. So that means my A value will be 3, and my B value would be left with 2. So pay attention to how they word that partition problem. Let's look at this question. Find the coordinates of the point that partition. I'm only going to do this one time. I teach my students to figure out the x and y separately. This equation's on the formula sheet, so use it. The formula is bx1 plus ax2 divided by b plus a. So what's my b? Who's got my b? 2. What's my x1? Excellent. What's my a? What's my x2? And what's b plus a equal? 5. Excellent. So now I've got 6 plus 18. That gives me 24 divided by 5, which is 4.8. Now I have my x. So then you do the exact same thing, but for the y. My formula is by1 plus ay2. So what's my b again? 2. What's my y1? Okay. What's my a? 3. My y2 is 10. So 2 times 4 is 8. 30. 38 divided by 5. 7.8. So that's my coordinates. My coordinate would be 4.8, 7.8. Do not skip, like, don't just Christmas tree this question. It's really easy if you take your time. Yeah. I mean, you just follow the formula. Here, no. Here it says perimeter and area. Draw a picture. You won't be able to write on it, but if there's no picture, just draw it. A, B, C, D. It tells you the points. There should be a parentheses. So because it tells you it's a rectangle, you know all you need to do is figure out 2 lines, A, B, and B, C. That's different than your performance final when you had to figure everything out. So what can I use to find the length of AB? Distance formula. Slope tells us rate of change. So we're going to do distance. I'm going to do the distance with the ear cap. So we've got -3, 0, 3, 2. We subtract. -6 squared, -2 squared. So this will be the square root of 40. Okay? You can do the distance formula the longer way. Basically, the distance formula, subtract the x squares it, subtract the y square it, add it up, take the square root. So that's my AC. Now I need my BC. So I've got 3, 2, 4, -1. Subtract each of these. This becomes positive. -1 squared, 3 squared. 1 plus 9 is 10. And so now you can find the perimeter by adding everything up. And just do this in the calculator. Don't make your life hard. That gives you the perimeter. Nope, because it told us it was a rectangle, so we only had to do 2. On the performance final, you had to do all 4 because it told you it was a quadrilateral. So this right here was AB. And because it's a rectangle, I know that this has to be the square root of 40 and this has to be the square root of 40 because opposite sides of a rectangle are the same. So the perimeter is we add it all up. The area is we multiply, which you'll get 20. I didn't need to because the opposite sides were the same. Good question. Gucci, we can go on. Next, this one, it says prove it's a parallelogram. Go back to the front of the page. Parallelograms, opposite sides are congruent. You could do distance formula, or you can do, I think it's easier to do midpoint because in a parallelogram, the midpoints, the diagonals bisect each other. Leo rides his bike 6 kilometers south. So pick a point. South is down. Oh, 9 kilometers south. 12 kilometers east. How far is he from his starting point? Who can hit? What am I going to do? Pythag. Yep. 9 squared plus 12 squared. 81, 144. 2. Oh, 225. How cool is that? 15. Ooh, here's a good one. A soccer field is a rectangle that is 90 by 120. The coach says he has to run the longest distance from one corner to the other. That's a trick question. The longest distance is always diagonal, always. So you're just going to do the same thing, and in this case, you'll get 150. 90 squared plus 120 squared equals what squared? And then you solve. Because I just did the math, I knew the answer. And technically it's because they're multiples of 9 and 12. 9 times 10 is 12, 9 times 10 is 90, 12 times 10 is 120, 15 times 10 is 150. But really, you would do the math out. Okay, and that's, hey, that's where we're stopping. Okay, good luck, work hard, watch the videos. EOC Math Review will link you to my videos. 4 o'clock on Sunday, we are having YouTube Live. Okay, 4 o'clock on Sunday. Thank you.